Well, hi, good morning. Thanks so much for joining me in my shop here for another round with this receiver. Situation's very different this morning. So the last video ended with a fuzzy looking S-curve. I was quite disappointed about that. I came in this morning, I just turned on my equipment, get it warmed up and get it going. Can you see what's on the scope there? Look. There's an S-curve. There's two of them there simply because of the way the sweep works. You can ignore either one of them and just concentrate on the other. So we could concentrate on this one. So this is what it's supposed to look like. There it is. If you notice on this diagram, there's a single curve and a straight line going across. So this would be from a sweeper with some kind of blanking in it in some way. The one I'm using has no blanking, so it's an out and back, sweeping in both directions, back and forth. So consequently there's no center line through here. That's fine. Holy smokes. So every other time I've done this, this center line has been located right up at the top here, more or less, and there was last time fuzz all over the place, but look at it. It's absolutely perfect, and I couldn't tell you what is different. I just came in, turned everything on. Life is like a box of chocolates, isn't it? And here's another thing. While we're looking at that S-curve, we could take a peek at the meter. Now the meter's in the middle because I tuned the radio, so it's in the middle. And I think it's the same deal with the on the scope. The S-curves are in the middle, more or less. Well, it's a happy day here. My intentions were to come in this morning and just start redoing the entire alignment process from start to finish again, in hopes I would end up with that S-curve there. But it's there now. So I'd also planned to utilize this sweep machine just in case there's something funny going on with the one I'm using. That's this machine over here. And that was causing the S-curve weirdness, which is no longer there now. So I have to make some decisions here about how to proceed. Is it worth it for me to go through the whole thing again? I think the answer is yes. Not that I think, for instance, the IF has become detuned in the process. I think it's okay, but I don't know that. So I think to establish knowing what the situation is, I do need to repeat a few things. So I'm going to back right up. We're going to take a look at the IF response curve. The IF response curve should look like this, or maybe look like that, either way. And we'll start from there and see if we can't ensure that the response curve is the right shape and the whole shot. This includes getting markers to show up. Oh my God, what am I doing? I'm shooting myself in the foot here. You know, really, leave well enough alone. No, I can't control myself today. I'm going to go through the whole thing and see. I mean, the idea now is I have a receiver which is working right, and you know, theoretically or hopefully is working right. So everything I see on my instruments is reflective of how I'm doing this test. It's no longer so. In other words, if I get a display that doesn't make sense, it's because of the equipment, the way I've connected it, something like that. It's not because of the receiver anymore. So okay, so I'm going to set up. We'll start with the sweeper I'm using now, the RCA. It's an RCA WR52 signal simulator, FM signal simulator. It doesn't even call itself a generator. And we'll see what we can get using that to begin with. Okay, so what I've done is I've reinstalled the temporary detector circuit that's required for making these tests. It's basically a very simple detector. You can kind of see some of it hanging out here. But I have the oscilloscope connected where the S-curve can be monitored. So I haven't moved the oscilloscope connection yet. I wanted to see what happens to this S-curve when you have that circuit connected there. I'm pretty sure it's going to disturb it. So I should turn on the radio. Very interesting. It might look to me like all that's happened is the amplitude is gone. I mean, just so this looks a little different. I see a bit of a curve in here. That this was pretty straight beforehand. So I think it's had a small influence. Not surprising and not important. I'm just curious. What we're going to do now, we're going to switch up from there to this point here. This should show us the response curve in the radio. Okay, and that's what we're getting there. Again, it's going to be two shapes here, but only basically it's the same thing twice. So you just kind of ignore one and pay attention to the other. Some changes I can make here. I can increase the sweep width here, like this. Not really changing the shape, just kind of moving things apart a little bit till you get up here. What's happening here is the sweep width is has become too small, and there we go. So we're looking at the response curve of the IF. Now I can make this look a little bit better if I do that and do this. So pictorially, this is what the radio is looking for. A curve like that. Now, this doesn't look right to me. It looks too sharp. But we need to determine a couple things. One is the radio being overdriven right now by my signal generator? So I'm going to turn it up, turn it down. Unfortunately, this is as low as it goes. And it looks to me like there's lots of room in the radio to have it much lower, you know, so it's much more down here than way up there. If I turn it up at all, what do we see? Okay, let me just shrink this a wee bit so we can get a better look at it. Actually, now when you look at that, and you look at this, why it looks closer. You can't really compare them so directly like that, anyway. Just kind of a loose way of looking at it. So now we'll increase the RF output of my generator here. Right away, you can see right away that this shape is changing right in here. You can see a flattening of the top. Look, it's just barely up. That's some kind of limit being hit there. All in all, I think this is way too strong. And so I have tried, maybe not on video, to pad this down. And everything I tried, resistors, capacitors, and this and that, the result is the shape changes, which is very disconcerting to me. I'm going to try to make adjustments in the radio to make this shape fit the ideal as shown, and if the way I've got the signal generator connected affects the shape, wow, I'm way off. I'm off to a very bad start. I wonder if that shape changes, the shape changes I was seeing, are really because the set's overloaded. And it may not be overloaded in the sense that the signal is too much. You know, if this was a radio station, it would sound terrible. It may not be the case. It may be the case that it's overloaded to perform this particular test. Now, what am I going to do? So I'm going to try and pad that down, and we'll see what we can do with it. Jeepers. I wish I could do some kind of variable padding of some sort. Let me think about this a little bit. Right? See if I can come up with something clever anyway. Is it just possible that there's a limit in my little detector circuit too, that it has a response curve of its own? I don't think so offhand. It's just possible that flat top was coming from some limit caused by the diode here. I don't think so, but I don't know. I'm just trying to think of every possibility. Right. Padding it. Okay, let's see what I can do here. Okay, feast your eyes on that. So up in the top left is the scope shot, and in the top right is the tuning meter shot, and in the bottom is the back of the radio with the detector circuit sitting here and the antenna terminals down there. Let's see what happens here. Now, I think my signal generator output frequency will change a little bit. You can see the guy here as I do this. I think I want the 19 kilohertz pilot off. Okay, so I'm just going to disconnect one lead from here. So let's just click it on and off and watch. So you can see the display on the scope jumping left and right. Now I think that's a tuning issue, but we don't. So I think the frequency of my signal generator is going back and forth a little wee bit. But interestingly enough, the meter's not changing. Or if it is changing, it's such a small amount we can't see it. Just to prove the meter, I'm going to tune the radio here. Now I've left this disconnected. Let's put it back on. Just start where we were. And there we go. Okay, so probably what's happening with the FM meter is it's interfered with. It's a little disappointing. I kind of expected it to do something. Is there something about the sweep? Let me take this off sweep. I'll stick it on mono here. Come on, camera. It's again automatic focus. Maybe it's focusing through the holes in the chassis there. Good enough though. Good enough for us to see what's happening. Okay, tune the radio a bit. What's happened to the tuning meter? Interesting display on the scope. I could bet that making the scope symmetrical is tuning it right in the middle. Well, I don't know why that meter's not working. I'm going to have to assume it's because I have this detector circuit connected here. Does that even make sense? I guess so. Yeah. No, I don't think so. Let's go back here. You know why I don't think so? Well, let's move the scope to where the S-curve once was. And so I've lowered the scope here. Let me raise it. Well, there's the S-curve. Distorted a bit. Why isn't the meter operating? My God, all these questions. Did the meter suddenly start when I don't know, but it's actually not germane to the situation right now. Whatever it is that's doing it, I'm just going to ignore it. Get back to what we're really doing, which is studying the earlier stages of the radio. The stages, the detector stage that creates the S-curve is actually really not important at this moment, so we'll ignore it. Oh, I like ignoring it. Okay, so now we do the pad down thing. We'll try anyway. First of all, one lead off, the other lead off, and pretty much removed it. Now I'm going to do some loose coupling here. I'm going to take this as just a coiled up clip lead. Don't know what this will do, but let's try it. Uh-oh. Okay, here we are. Not that this meter's too important to us. Scope shows absolutely nothing getting through. So now I'm gonna, what I'll do here, they're close together. I'm gonna loop this through the loop and clip this together. Get anything yet? Get a little tiny thing showing up here. It's almost invisible. Okay, what if we crank up the output now? Oh, much better. Much, much, much better. So is this valid? The instructions have instructions on how to terminate the leads here, terminate these leads. That termination's in here. It's kind of a standard thing. Of course, that's not involved now. I've put a short on the FM antenna. I'm going to go with the idea that this is just fine. Now we have a curve that looks much more like what it should look like. Funny bump in it. I can grow it up a little bit. It looks really nice now. But what we don't know, just ignore one of them, what we don't know is the bandwidth on this. To determine the bandwidth, we have to introduce a signal into the radio. And to do that, I've got to use another piece of equipment here. Just switch off my soldering iron. So I'm going to get another piece of equipment set up and see if we can't make a marker show up on there. Okay, so I've brought in this Field Tech unit here. And I've had trouble with this trying to make it work because it appears to have signals coming out of it aside from coming from the port here. It just seems to be coming out of the box. Unfortunately, I cannot get the screen to show up. It's way too bright on camera. So you'll have to trust me when I tell you what I'm doing. And right now it's set for a very high voltage. 10 volts on the terminal, sine wave, and the frequency it's set to is 10.3 megahertz. And every time I snap this, it's going a point. It's going 100 kilohertz up and down. So if you watch the scope, I'm at 0.3, 0.2, 0.1. What? 10. 10.9, and at 9.9, 8. What? So if I just look at this thing, that's 11.1. So I was going to use this to produce a 10.7. Here's a 10.7 right here. 8767876. There's no cord plugged in. It's just sitting on my bench here. Well, first thing I can do, I can move this some distance. Let's do this. Move this around. Let's set it to something that's a little more sensitive here. Okay, and I move it around. Look at this thing. Look at this thing. It's not hooked up to anything. Well, it is actually. I've got a ground wire going. What if I take the ground off it? It's still influencing things, or is that simply my hand waving around? Well, my hand's doing it a little bit too. And I'll set this. Oh! Somehow this got. Oh, what happened there? Wow, the frequency got way off. Let's take it back up there. 10. Sorry about this. What's happening now? Now it's not producing any thing. Well, yes. That's 11.1 again. Oh, it's not doing what it was. Oh, the ground was off. Is it really just the ground? Put it back on. Maybe that's making the ground wire into quite an antenna. So we seem to get a bigger effect there. Okay, put it down. Just take the ground off. Oh, just reaching for it. What happened there? I don't think I can use this in any way. I mean, it's just having it in the shop here. What if I turn it off? Well, it gets rid of it. And you know, there was snow in here too. Well, funny. You'd think a nice, gentle, modern device would. It's got a plastic case. It's not a metal. It hasn't got a metal case, and maybe that's the big problem with that thing. Okay, so that just went down the drain. My number 2 option is to try to bring on, oh, not this guy, but the machine behind it. This one's been causing me some trouble. I'm a little afraid to use it right now until I investigate that. I don't care to do it right at the moment. I have another signal generator. It has problems too. Son of a gun. Somebody's got to give me 10.7 megahertz. Who's going to do it? Okay, I'm off in search of a 10.7 megahertz frequency that I can utilize here. Okay, so what I've done is swapped out that camera on the tuning meter in favor of a look at my SDR. The SDR, have a look. The SDR is hooked up to nothing but the output from this guy right now. There's a sweep generator. He's set right close to 10.7. I'm going to move the sweep. You see the sweep moving around. I'm going to move it out. We're not really interested in the sweep. The sweep is actually not what we want to see. What we do want to see, though, is something at exactly 10.7. Now, what I'll do is I'll stick the red line. Oh, the red line's already right on 10.7. And you see there's something there. This is really curious to me. What I really intended to do was not use the sweep oscillator, but use the marker oscillator here. Marker oscillator doesn't actually go down to 10.7, but through some magic of I don't know what, it can get a 10.7 signal out of here, and many harmonics. I don't know exactly why, but even weirder than that, let me turn the marker off. Right on the red line. Watch. A signal shows up. Two signals show up. One shows up here and one shows up down here at 10.570. So, well, that's just because of the setting of the frequency control here. So I'll change the frequency setting here. Those guys don't move. Is there a chance that inside this machine there's a crystal I don't know about? It's a mystery to me. Why? And I double checked the calibration on my SDR. I used that noisy signal generator. This guy. I just used this guy. Turn them on, set it to 10.7. Double check the SDR. It's dead on. SDR is dead on. So we have a signal. Appears to be coming out of here at 10.7 for reasons I don't even know. It's kind of weird in a way. Let me just change the attenuator here. So you can see the sweep got much stronger, but there's also another signal, and that's this one here. 10.92. I'll vary the marker frequency. We should make sure it's, I'm going to turn up the marker level. So you can see something going on over here. As I change the marker level, which is probably throwing the frequency up and down a bit. Doesn't seem to be related to the level of the signal. Oh my God, how crazy. I'm right on the edge of the pan now, looking down into the fire. What can we do with this? How do I know this is really coming from here? Maybe there's an FM radio on somewhere. Maybe. No, that doesn't make sense. That doesn't make sense. Oh, this is pretty curious. Let me turn this generator right off. Away it goes. Back on. Let me disconnect the SDR from the signal generator. It kind of goes away. I think it's still there, just barely, just from closeness here. Well, for crying out loud, there's a 10.7 signal sitting there. Don't know where it's from, can't control its level, so it seems. There's some other signals with it. So is that going to be a problem? Oh, this is a long shot here. I don't know how strong this signal is. I'm going to jam this into the IF of the radio, and when I do that, it's probably going to disturb the radio in various ways too. So in order to allow for that, it's hard to see in the camera there, I'm sure. There's a capacitor sticking way out here. You see it there? And that's hooked up basically to the front end of the IF. All I got to do is just make this clip touch that wire, and we're shooting whatever it is, we're shooting right into the IF. The hope is that something will show up here. This has become a little shaky. Still looks the same though. Looks wonderful. In fact, the shape is perfect. The shape is reassuring that I'm not overdriving this radio or doing any other crazy stuff. Just realize my phone is in my pocket, so you may have been listening to my phone clicking away there. Well, I should hook it up and see what happens. So the first thing is this ultimately ruining the test setup when I make this connection? I'm going to bend this upwards here. Okay, just touching this stuff. I'm absorbing a little bit of the IF signal and just getting close, even just getting close to it. What fun. Okay, now I'm going to make the connection. I've got to turn off this radio when I make this connection because I'm just a little worried. Radio off. Worried I'm going to spark the radio and blow something. Some little component. And we don't. Now the signal, the sweep signal, I'm going to try to weaken it as much as I can. Interesting enough, that 10.7 thing remains. I don't like this too much. I'm not sure where that 10.7 is coming from. Well, I know it's coming out of the signal generator because I turned it off and it disappeared. What's this other really strong one here that's just remaining? That's at 10.57. I'll turn off the generator. It goes away. It's really very mysterious to me. Back to the 10.7. Why these would exist in the output. And trying to turn up that. No. Maybe just a wee bit. Yeah, I can get it to go up a little bit with this controller. This one, no. So this one, if it were to zero out, it would zero out the sweep. Sweeps off to the side, 10.2. It's far enough away, I think. What happened on our... Oh yeah, I don't have a rate receiver going. I looked at the scope about... Oh no. Okay, on with the... look at that. So what's happened is I've introduced a huge amount of noise right into the IF, and it's... yeah, this isn't going to work like this. Not going to work like this. So I'm trying to mark it. Not necessary. It's not necessary for me, or is it? It's not necessary to send it through the IF, the 10.7. I just want the 10.7. That doesn't make sense. I'm not making sense. Okay, before I get even more senseless, I'm going to stop for a bit here and ponder the whole situation. Well, I had one of those thoughts for a moment that really didn't quite work out, but here I've got a sweeper set up to sweep right into the front end of the IF, right after the tuner. And I've got everything set up to see what the response curve should look like on my oscilloscope. And I've got the SDR sitting there so we can actually see the sweep range and everything on it. So if we do look at the SDR, the sweep range is pretty much centered on 10.7, and it's going way out. This is 11.2 way out here. A huge sweep way out of the bandwidth of the IF. But on the scope, look what we get, this really weird shape. Now if I fiddle with the input level, the amount of signal strength at this point here, I reduce it a lot, I increase it a lot. Down here, we're down in the range of the noise of the radio itself. Turn it up a little bit like that. Anything like a response curve showing up. When I can move this frequency around, this is kind of the weird part. So right there, if you look at the SDR, what is going on the SDR there? It looks like there's you know what, this is probably multiple frequencies coming out of here. Anyway, failed experiment. That was the whole point of that. Gave it a shot, didn't work. So, and in doing this too, I tuned the antenna generator, if I can call it that, off, so it's not involved. So that didn't work. So what I'm left with now is trying to use my big old military signal generator. Seems to me, from what little observations I had with it, it works for a while, and then at some point it loses its mind. So maybe we can use it for a while. So I'm going to set up for that and see if we can get away with this. Sooner or later I'm going to be able to do something here. Somehow. Okay, ready to go. So the sign that there's something going wrong with this machine is this level meter goes over and pins itself really hard against the top. So hard, I'm worried I'm going to burn it out if I leave it too long. So I got to keep an eye on this meter, but I think it will work initially. And what that meter's showing is one of two things. Either it's showing modulation percentage, it would be now, or if I do it like that, it will show the voltage output at the terminal. Sort of. I think we're ready to go with this. Flip it on and hopefully I get 10, 15, 20 minutes out of it before it starts going bonkers. Still have the SDR going, so we can be sure of the frequency we're working at. That's the idea there. How's that going to work? This is my SDR antenna sitting over here. Still got wires hanging out of the back of the radio. I'm going to try to shove this 10.7 into the IF same way as before. The impedance of this lead is going to be somewhere around 300 ohms or so, based on a little box I'm using here. But I haven't actually connected it. It's actually clipped to the rubber of this clip. It's actually not directly connected. Hoping there'll be enough there. Don't want it to disturb things. And as for this, you know what, I got a frequency counter going. I'm not going to worry about the SDR right at the moment. We're going to rely on the frequency counter here. So I'm going to turn it on. It's a very stable machine. As soon as it warms up, as soon as it comes on, it's ready to go. I'll dial up 10.7. You have the level fairly low. I have to calibrate. This has to be all the way there to do the calibrate. It won't be terribly accurate, but it doesn't have to be. At least I'll know there's roughly what kind of voltage is at the end of this wire. The wire I'm sending it over with. Okay. Let's watch that meter, just see if it doesn't go right over right from the start. Because I have not investigated this problem. I've just seen it twice, and it concerns me a lot. Watch the signal generator start coming on. There goes the meter. It's going up. It's settling where it should be, I think. Okay, don't waste time. So this is the level. I'm going to turn it up here. Supposed to be up there, but that's too close to the top already, so I'm going to set it here and keep our eye on it. Maybe it's going to go like this, or maybe it's just going to drift up. And it may be it's still warming up at this point. We have not quite 10.7 here. We'll turn it to 10.7. 10.7 would be 698 or so. My counters are just a wee bit off. We have a 10.7 signal. Can we make it appear on the SDR? We probably can. Okay. Anybody? Somebody? Nobody? Ooh, that just wiped out the scope signal. My SDR survived? Did it survive? We'll have to trust this, but it's quite reliable. What's a couple hertz between friends? Now, is anything getting into this? So now we got to turn our attention to the oscilloscope. What we're hoping to see right now is a fuzzy little spot here, but it's kind of fuzzy as it is because I've made it so weak. I need more signal here, so I'm going to fiddle with the antenna arrangement. What I'm going to do, let's see, pop this open, wrap around once. I'm going to make this more of a transformer here. It's getting almost back to where it was. But I have this option. Excellent, excellent. See up in here, it looks like it's distorted a bit. Hard to say. We'll leave it about here. How's that meter? Still doing okay. Okay, so I'm going to raise the output of this and watch for something to pop up right on the money. Here we go. Okay, so something has popped up. It's popped up just on the side here. Meter's still good. Let me make sure this is just as close as we can get it. What's that doing on the display? You can't even see that movement. Well, you can now. So, okay, so we just get it right in close. We're okay. That's good. So it's telling me this is not tuned to 10.7. The IF is responding to, well, I can find out. I'll move that little squiggle. Very hard to see. Right to the top. Okay, so the squiggle's dead on the top. 10.6. Now, I've been here before. Is this because of disturbances in the way I'm doing things? Have I? Because, you know, there's no way of looking at this and it's dead on. How could it be too far out? How could it be far out? We have the S-curve going. We have everything going. Boy, oh boy. So pretty easy to set things up, have a problem in the setup, and then drive the radio into no man's land over your setup. I've been exactly here before. Okay, another way to examine the IF is to take the SDR and we're going to loosely couple it also to the same point as the scope, except I'm not using the detector. I'm going to go ahead of the detector, so to speak. What did we get there? What did we get? I wasn't really watching when I did that. Okay. So what if I raise the signal level here and watch that SDR? So that is kind of showing a response now. Kind of, but wow, according to this, it's a mile wide. It should be, you know, 100 kilohertz or so on either side at 10.7, so we really should say 10.8. By here, it should be down, or down to the zero line. So, you know, wow. If this is true, if the SDR is true, the bandwidth of the IF is really wide, and if it's off center, it's still wide enough to swallow the whole composite signal that's coming at it. Problem is, it can swallow other signals that are adjacent and stuff like that. I don't want the bandwidth wide enough that every FM station in Ontario is coming in your radio all at the same time, which would be pretty interesting. Who to believe? We don't know. Now, one thing about this frequency is that even if this is off for some reason, I should be able to measure the width of the response curve. So what am I doing now? The meter's still okay. We want to vary this frequency and kind of move it the dot, say from here over to here, and see what that bandwidth is down there. Where'd it go? Where'd it go? Maybe because I turned this up, it kind of overwhelmed the marker. Yeah, there's the marker now. There's the marker. It's right here. If it can't be seen on so ignoring the absolute numbers, we'll move it down. So at this point, it's down around here now. That says 10.77. So we got this is kind of sweeping backwards, if you like. This is the higher frequency and the lower frequency sides over here. Well, we would want 10.8 to show up. I don't understand what I'm doing here. What's happening? This is some kind of weird cognitive thing. So that's 10.8. Let's look on that curve. Where's the camera? Here's one. 10.6 and 10.8 to be up high on the curve, not down here. Okay, so that's one side shows 10.8. Now we'll go to the other side. Remember, the absolute value doesn't mean much. Come down about the same distance. So I'm right over here now. That's 10.4. So we have 10.8 on one side and 10.4. 10.8 on one side and 10.4. That's 400. That's 400. That's 400 down here on this curve. So that's not so bad. It's 100 here and 200 here, or 400 from here to here, which is just what I kind of measured, 400. It's right up near the top, up around this area here. Okay, so we'll go up there. Okay, so maybe I'll use this line here to do it. So it's about set on the line there. Now that's 10.55. 10.55. Where's 10.5? Where's 10.5? 10.5, a little further down the curve. So putting it back where I want it, right up around there. 10.5. Should be 10. Shouldn't be 10.5. Should be 10.6. If we put 10.6 on here again. 10.6 right on the top of the display. Oh, when I add all this together, what it suggests to me is the bandwidth is set way too wide. And let me just make this go again. So, look at the SDR. You say, oh, this, let's just pretend this is the response curve as best an SDR can do it. Right in the middle is 10.6 again. Two things telling me the IF is tuned to 10.6. That's great. Do I believe it? Do I believe it? Well, you know what I can do? I can strip off some test equipment here. We can keep an eye on the SDR and see if things don't shift in some way. So let me get this decay going again a little bit. Don't know what this tall peak is. It must be my signal generator. Is that what that is? Meter's still okay. Yeah, that's the signal generator. That's the marker. So if we mark, yeah. Oh, what just popped off? Ooh, look out, flying clip lead here. This is the loosely coupled, very loosely coupled SDR. couple it more firmly, but I don't think I need to. I have a big resistor there I could clip on if I wanted, but I think we're okay. Got enough signal here to do what we're doing. What are we doing? We're stripping off stuff. So first thing is, well, what's the influence of the oscilloscope? Nothing whatsoever. What's the influence of this guy here? What are you doing, Jim? I'm going to take off, this is the 10.7 from the signal generator. The meter's still okay over there. Take this off and pull it away. You can see the 10.7 melt away, but there was no shift in the response. Wow, this is all telling me it's not right. It's on 10.6, not 10.7. After all the work I've done, how could this be wrong? I have aligned this thing like a dozen times. Well, I think if you have a really wide bandwidth, you have a stupidly wide bandwidth that captures the entire signal, you could tune the radio. You could tune the radio. Okay, so this is the station signal, and the radio tuning is going like this. It's really wide, so you can be way off. How does that achieve a 10.6 instead of 10.7 in this test? I can't think my way through anything other than the IF is not aligned properly. Too wide and wrong frequency. So the question is, do I dare attempt to fix that here? It took me a long time to get that shape. Now, most of that came from ear tuning, come to think of it. So maybe that's what I did. Through ear tuning, I just widened out the bandwidth, too wide for the radio. And that's what I did. Now, there is something we're not looking at here. It's something I haven't really thought about, and that's the local oscillator in the radio itself. So you're mixing the local oscillator, which is going to be the tuned frequency plus 10.7. The tuned frequency right now is 100. So at 110.7 there should be a local oscillator. At 110.7. Okay, got to make lots of changes to get that to show up on the SDR here. I'm just going to go ahead and do it. So the first thing is we stop. Now here we switch this to quadrature sampling. Okay, now we go up to 110.6. Wow, that was pretty easy getting there. I have to change the antenna connection on my little SDR here. This is something I haven't finished setting up properly, so I don't have to do this kind of stuff. But I have to now. I have to change it. There's other SDRs you don't have to change inputs when you're changing bands, but this is a El Cheapo guy. What do we end up with? Okay, let me turn off the decay. Oh, turn it on. Here, let her rip. Okay, what do we see here? 110.7 is here. Not quite. There. That's where we think the local oscillator should be. What's it doing? Is this it? This is probably it here. The SDR would pick this up just because the local oscillator is usually quite strong and the signal is leaking around inside the radio. So the SDR can just get it out of the air. So I'll tune the radio and we'll see if this thing at 110.250 doesn't move. Here we go. And there it goes. Okay, fantastic. So this will allow me to properly tune the radio, assuming the local oscillator is tuned properly. Let's just put it this way. I will know when the local oscillator is running at 110.7. Now let's put it there. See what happens here. Who cares about the instructions? Who needs them? So 110.7 would be there. So we're tuning the radio. It's terrible, terrible. This is a terrible radio to tune, at least the FM side. You have to turn the big wheel. It's the only way to be precise. There. Oh. Okay, so this radio should now be receiving 100 megahertz. There. I can't get it any better than that. Or the local oscillator should mix with 100 megahertz to produce a 10.7 signal. Now look what's happened on the now it could be I'm not sending 100 megahertz here. Let's just adjust this. So 100 megahertz from my experience is sitting right here on this signal generator, and this would be not 100. This would be about 100. I wonder if that means we should really just pay attention to this first one here. I believe what I've done now is I have the radio tuned so it's properly picking up 100 megahertz. Okay, let's go back. What should we do here? We should go to 100 megahertz. What do we see there anyway? There's the what we're seeing here is the sweep. I'm just going to move this over. This is the sweep output here. Now, I guess it's a good idea to look at this. It's almost a megahertz wide, but we don't need it that wide, do we? If we're tuned to 100, and the bandwidth is like 100 kilohertz or so, it should just be sweeping right in this area here. The sweep is way out, it's not centered. What's happening there? I have no way to, yes I do. Let's shrink the sweep down, shrink her way down. So that big thing is just what's left of the output of the sweep generator. Just a hair off 100. What other indications have we got left now? Well, one of them is, hey, what's going on with that tuning meter? Tuning meter is just sitting in the middle. I think it's really disabled by the detector circuit I have running in there. Okay, so much going on. Okay, output meter on my generator still good. Hasn't gone off. Quickly, man, think. I've got so much in my head now. Well, shouldn't that SDR frequency be right on 100? How can it not be on 100? Why did I think that was the right spot? I'm losing it. I'm losing it everywhere. I'm losing my religion here. Gotta stop for a while and calm myself down. Too much juggling, too many balls. Oh, balls are hitting the floor. Uh-oh. Well, this is what has come to mind now. I guess I'm a little slow at thinking things up. Which one of these am I really supposed to think is the right one? How did they end up separated here? So the sweep frequency is going like let's say 100 in the middle. Where's the middle? Is that the middle? Is this one the middle? Why are these off? Does it even matter? Because I've got a 10.6 signal doing that from the signal generator. so many indications it's not correct. I'm just wondering if it's because of the way I've set things up, it can't be correct. Well, what have I done that would do that? Attach something to the front of the IF. Let me detach something from the front of the IF and watch the scope. Didn't move anything left or right. Just took some noise out, and I don't even need this here. I can loosely couple the SDR other ways. Stick it here. So how does that do it? Does that do it? Kinda. That's not the SDR. That's the signal generator. Confusion, yeah, I'm overwhelmed. I'm overwhelmed with all this. The conclusion I'm reaching is clearly, the clear conclusion from this is IF is still not aligned properly. Why that is exactly, I don't know, but I think I had something to do with it. Numerous times I've set up this kind of test, and almost every time I find there's like 100 kilohertz error in the alignment. So I'm really hesitant to get in there and start monkeying around with it. In other words, I don't believe what I'm seeing. How can it be any different though? I'm basically feeding a single frequency through the IF using this signal generator over here. That's a really simple way of checking the frequency on a IF. I've taken the clip and done stuff. It doesn't seem to be disturbing. The deal I'm too hesitant to go in there and start doing stuff. And I think I've reached the end of the road today. I'm going to pick it up from here tomorrow, and I have the day to think about this a little more before I start going through the whole process again. But I suspect it's simply out of alignment, and I just booped it up earlier. As I said, I did a lot of it by ear at the end there out of a panic. Don't want to panic. Okay, well, thanks a lot for watching to this point. I'm certainly in the zone here. So that's good. That's good. And I hope you enjoy your day. And I'll spend my day scratching my head a little bit. See ya.